In this video, I'm going to provide some tips on working with the debugger for CS240. So I'm assuming that you've had some exposure to the debugger in CS149 or CS159 or whatever other prerequisite classes you've taken, but you may not be in the habit of using it consistently to track down problems in your code. And I would argue that the kind of programming that we're doing in CS240 makes it really difficult to be successful if you're not comfortable using the debugger. So if you've been getting away without it in the past, it's probably time to start practicing using the debugger. And my plan here is that I've set up a simple class and I've intentionally introduced an error, and I'm going to sort of walk through the process of how I might use the debugger to track down that error. So, and we'll also talk a little bit about how to make sure that VS Code is configured correctly to do the kind of debugging that we need to do. So first, let me say a couple of words about this class that we're debugging to give you some context. I'm writing a singly linked list implementation of the Java set interface. How is this set up? I've got a couple of instance variables, a head reference that is referring to a node object, a size field to keep track of how many elements are in the set. I have a private inner node class. Each node object has an item field and a next node field. That's got a constructor. I have a constructor for my simple linked set class that initializes the head to be null and the size to be 0. And the only two substantive methods that I've written so far are add and contains. How does add work? Well, it first checks to see if the item that we're adding is already in the list. If it's not in the list, it puts that element at the head of the node and increments the size and returns true, indicating that the list has been, or the set has been modified. If it was already in the list, then we don't do anything. We just return false, indicating that nothing changed. The contains method is just our standard loop for iterating through a singly linked list. And we check every node in the list, the item stored in that node, against the item that we're searching for. And if they're equal, return true. If we get all the way to the end and we haven't found it, we return false. So this looks great. And of course, if I've written a couple of methods, I'm going to pause at this point, write some tests, make sure that they work correctly before moving on to the rest of my implementation. So I've done that. Got a couple of quick tests set up here. My first test just adds an A to this set, and then it asserts that the contains method will return true if I search for an A, and it asserts that the contains method will return false if I search for a B, which I haven't added to the set. And then I have a slightly more complicated test where I add A and B. I add two elements. I check to see that they are both contained, and I check to see that some third element is not in there. So great. I'm going to run these tests. I'm going to click over here on the testing pane in VS Code. I'm going to find my test class, and I'm going to click the Run Test button here to run all of those tests. And unfortunately, one of them failed. So the good news is that test 1 item succeeded, but test 2 item failed. It looks like even though I've added A and B, my set is reporting that A is not contained. So what do I do at this point? Well, I could certainly spend some time, and I should maybe spend some time looking at my add method and my contains method to make sure that they look like I'm doing everything correctly. But maybe I do that and everything looks fine. And I can't sort of see what the problem is. So what do I do at this point? Well, I might go to instructor office hours and ask there. I might go to TA office hours and ask there, have them look over the code with me to see if we can find the problem. But what I really want to do is be able to sort of get some data on what's going wrong. And that's where the debugger comes in handy. Now, the debugger won't tell me what's wrong with the code. What it's good for is helping me to compare what I believe my code is doing to what the code is actually doing. So I've written the code. I think it's doing the right thing, but it's clearly not doing the right thing. So somewhere it's doing something that doesn't match my expectations. And the power of the debugger is that it allows me to check my expectations against what the code is actually doing. So what will I do in this case to use the debugger? I'm not going to worry about debugging anything that's happening in this test 1 item method. Presumably that's all working correctly. So I know that something is going wrong in my test 2 items test. So something goes wrong between when I create this set and when I check containment here. So really sort of attractive place to set a breakpoint is just at the beginning of this test. So I'm going to click over here in VS Code to set that breakpoint. Now I'm going to go back over to my my testing field over here. I could debug all of my tests, but I know that the test I'm interested in is just test 2 items. So rather than clicking the run test button here, I'm going to click the debug test. And sure enough, the debugger stops execution of this line of code. It's highlighted in yellow. There's a little symbol there indicating that that's where I am. The variable field, the variable box is up here. There really aren't any variables, any interesting variables to look at yet because I haven't executed any of the code in the test. So it's time to start stepping through my code. The buttons to control the debugger are up here. This button is steps over. It's got this little jumping arrow symbol. This button steps into. So stepping over means that we're going to execute the entire line of code. Stepping into means I'm going to step into any methods that are called in that line of code. So my rule of thumb is I'm never going to step into a line of code unless I already have some good reason to believe that something is going wrong with that line of code. I don't want to waste a lot of time stepping through or stepping into a lot of methods if those methods are actually working correctly. My other rule of thumb is that I'm never going to click either of these buttons unless I have a prediction in my mind about what I expect to happen. Remember, the power of the debugger is it allows me to compare my understanding of what's happening in the code to what's really happening in the code. So if I don't take the time to think about what I expect to happen, I won't notice when something goes wrong. So in this case, that means that I have to have a kind of mental model of what I expect my set object to look like after it's constructed. And what's that going to be? Well, I'm going to have a set object. It has these 2 fields. It has a size field, which should be 0 because I haven't added anything yet. And it has a head field, which should be a null because, again, I haven't added anything yet. So let's step over and take a look and see if reality matches my expectations. If we look over here in this variable area, we see that this set variable is now initialized. It's got a simple linked set object in it. Unfortunately, somehow this debugger isn't letting me see the contents of that object. What I want to see so that I can compare against my mental model, I want to see the values of these instance variables. But it's not showing it to me. And that's because I need to right-click this and click on Disable Logical Structure View. What's happening here is that by default, when the debugger is showing me the state of some collection type, it's hiding from me all of the internal details of how that collection is implemented. Because normally that's what we would want, right? If I'm working with an array list in some application that I'm debugging, I'm not worried that the array list is coded incorrectly. I don't want to look at the internal fields of the array list. I just want to know from a user's point of view what's in that array list. But the scenario here is different, right? It's as if we're coding the array list. We need to see what's happening internally in the memory of the array list, or in this case, our simple linked set, so that we can debug it effectively. So this is a case where the default setting for the debugger is acting against what we need to do in CS240. So I'm going to click Disable Logical Structure View. Great. Now I get this little eyeball. And if I click on that, it expands my simple linked set. And I can see the values of the contents of the instance variables. And sure enough, it matches what I was hoping for. Head is null. Great. Head is null. Size is 0. Size is 0. Fantastic. So everything's looking good. Okay. So let's go back to the debugger here. Here we are. I am now going to step over this add method. And before I do it, I'm going to, at least in my mind, make sure I have an understanding of what I expect to happen. And what I expect to happen is that it should create a node object, which will be the new head. That will have an A in it, and its next field will be null, and the size should become 1. So that's what I'm expecting to happen when I add A. So let's add A and see if that's what happens. Okay, let's take a look at the set. Size is now 1. That's good. Head is now a node object. That's great. That node object contains an A, and the next field is null. So it's looking good. Everything is matching my expectations, so it looks like nothing went wrong with this first call to add. So, well, I'm going to now add B. So what do I expect to see? This implementation is designed to add a newly inserted elements at the beginning, because that's going to be the most convenient thing. So after adding B, I'm going to expect that I'm going to have something like this. My size should be 2. My head reference should refer to the newly added node B. Its next should be A, which should still have null as next. So that's what I expect to happen. Let's step over and see if that's what happens. Size is 2. That's great. Head is B. That's good. Wait a second. Next is null. So somehow my add method didn't correctly attach A into my list or leave A in my list. So I now know that there's something wrong with my add method, and that it goes wrong when I add the second element. So at this point, I'm going to stop the debugger. I'm going to start it up again from the beginning. And this time, when it gets to the point where I'm adding B, I'm going to step in so I can watch what happens during the process of that add to see where something went wrong. So I'll just step over constructor, step over adding A. I've already inspected these things, but now I'm going to step into add for B. Well, I don't know, is contains going to work correctly? Let's check. What do I expect to happen when I step over this? Well, I should expect that since the item I'm adding is B, and B isn't currently in there, contains should return false. So I should get into the body of this conditional statement. And sure enough, I do. So there's no point in stepping into contains at that point because it gave me the answer that I expected. Oh, and now I immediately see the problem. I'm about to create a new head node. That would be this B node that I'm adding. But when I create that node, I'm setting its next node to be null, but its next node should actually be the old head. It should be that A node. So here's the mistake that I've made, and I tracked it down by using the debugger. Excellent. And that's what we hope happens. So let's bring Eclipse over here in case you're an Eclipse user. Everything is going to work pretty much the same in Eclipse. Can go over here to JUnit to run the JUnit tests. Let's say we've gotten to the point where we know something's wrong. Setting a breakpoint works in exactly the same way. I'll put that breakpoint right here. Doesn't want to go there. That's okay. Then when I'm going to run my JUnit tests, I will, rather than running as JUnit, I will debug as JUnit. Ask if I want to switch to the debug perspective so that I can see the sort of view of things from the debugger's point of view. In Eclipse, the variable fields are going to be over here. The buttons are up here. They have the same meaning. Everything is pretty much the same. In fact, VS Code uses a lot of the same code as Eclipse behind the scenes, so it's all very consistent. I'm going to step over. I can see what's going on. Uh-oh. Now I try to look inside this set, and I'm actually getting an error here. This is the same issue that I was seeing before in VS Code. It's got exactly the same default of not showing the internals of a collection type, but instead showing us some high-level user-level view. In this case, the way to turn that off is here. The Show Logical Structure button is this button here, so I'm going to click on that, and then I get the head and size fields. And now I can go through that same process of debugging my method. So one other thing I want to show for Eclipse is that, let's say I'm going to debug it again. And let's say I wanted to step into my constructor. start stepping through what happens here. Great. Didn't happen the way I expected. Let me try that again. Debug. Step into. Oh, here's the thing that I was worried about. It says source not found. Who knows what's happening over here? My call stack is looking very big and complicated. Somehow I've accidentally jumped into some of the source code for the Java language itself or some sort of part of Eclipse, which is not what I want. So I can keep kind of stepping along to try to get back into my own code, and eventually I will, but it's very distracting. Right? And what's happening is that when we run our code, it is often the case that we take advantage of external libraries, JUnit, for example, and we don't really want to step through that code because we believe that it's implemented correctly. So the way to, and VS Code is already configured. We've already configured VS Code for you to bypass those libraries. Let me just quickly show you how to do that in Eclipse. We would go to Windows, Window here, Preferences. We go to Java, debug, step filtering. We want to turn on use step filters. And I would say just turn all this stuff on. We don't really want to step into any of this stuff. We only want to debug through our own code. And I'll even add a filter for org.junit. That's a wildcard that says anything in org.junit. Okay, and then I'm going to apply that and close. Now, from this point onward, that shouldn't be an issue. Eclipse won't step into library code. Okay, good luck with the debugger.